having a little snack, jelly beans. So, back in objective 1, talking about rational exponents and nth roots. Those two things mean exactly the same thing as we just saw. So take a look at this, again at this equation. So far we've talked about, say, an exponent that's 1/2, but now we have 3/2 that's on the bottom of this one. What does that mean? And we're going to examine that in this video. Okay, so summarizing the stuff about nth roots, real nth roots. The imaginary ones will be part of the challenge for this section. Okay, so n is any integer that's greater than 1, and n is our index here, whatever root that we're taking. And a is just a real number that we're taking the root of. Okay, so now let's examine it if our index, our nth root, is an even root. Well, if a is negative, you don't have any real ones. It's like taking the square root of -4. It's both imaginary. Okay? If a is equal to 0, then you just have one real one, and it's just 0. Like the square root or the fourth root of 0 is just 0. Okay? And if it's positive, then you have two real solutions, a positive one and a negative, like we've done before, where the square root of 4 is equal to a +2 and a -2. Okay, let's switch over to the other side, looking at if the index is an odd number. So we're talking about the cube root or the fifth root of some number a. So if a is negative, doesn't matter. You can take the cube root of it, and you get one answer, and the answer stays the same sign. If a is equal to 0, you also get one answer, and it's just 0. And then finally, if it's positive, you also get one real answer. We're supposed to have 3, so for example, if this is cube root, this means r raised to the third power is equal to x. I'm supposed to have 3 of them. And if we're talking about on the right-hand side, we're only having one real, what must the other two be? Imaginary. Okay. So in other words, even roots have two solutions, positive and negative, and odd ones only have one of them, right? Okay, and also the even ones, they have to be non-negative. We don't want, you can take 0, right, but you can't have a negative number in there. Okay, odd roots only have one real solution, and they keep the same sign as the radicand. And then finally, since they only have one real solution and you're supposed to have 3, the other two must be imaginary. Well, if it's cube. Same thing with anything that's odd. Alright. So, now let's talk about when it's an improper fraction. Like back at the objective side when the power was 3/2 instead. So exponents, rational numbers, can be any improper fraction, improper or otherwise. Okay. So, right down here in the middle, let a to the 1 over x be the nth root of a. It's like we were looking at before. M is a positive integer. So here is our first little rule. A raised to the m over n is the same thing as a to the 1 over n. So this might be the 1/2 power of a. All of that raised to the m power. Well, what's inside the parentheses is the same thing as the nth root of a. Still, all this raised to the m power. And usually, whenever we evaluate these things, we do the root first because that makes the number smaller, and then we do the other exponent to make it bigger again. Okay, and then over there in the green box, this is the exact same thing as what was before, it's just now our exponent is negative. What happens when our exponent's negative? That means reciprocal. It means I take my number and I put it on the bottom of a fraction. Okay? And then everything else is the same. We have to make sure that that number a, though, is not 0, because then I'd be dividing by 0 black hole. So, let's try a couple of these. And let's see. 16 to the 3/2 power now. So, this means now the one that's on the bottom is the root, right? Because that's what we're looking at, like 1/2 power. So this is the same thing as the square root of 16, and then all of this cubed. Do the square root first because that makes the number smaller. So the square root of 16 is 4, and now I'm going to cube that. 4 times 4 is 16, times 4 more, 64. Okay, over here on number 2, when I have that negative power, I need to put my number 8 down in the bottom of a fraction. So this should be equal to 1 over 8, and now the 3 that's in the bottom, that's the root. It's 1/3 power, so that is the cube root of 8 raised to the 4th power. So the cube root of 8 is 2, so this is 1 over 2 to the 4th power. 2 times 2, 4 times 4 is 1 over 16. So there are some instances where I have some improper fractions and some negative fractions as exponents. Now notice that both of these numbers were rational. Let's take a look at these. I'm going to have to pull up the calculator for these because these aren't going to simplify easily by hand. So calculator again, and this thing is totally in the wrong place. Okay, so the first one, 35. So 35 raised to the, make sure you put your exponent in parentheses, 5 divided by 6 power. I just said parentheses and I didn't do it. There we go. And parentheses. So I get this number. And if the decimals keep on going, that's an indication that your number is probably irrational. Okay. So 19.4, I'll round it off to, is approximately 19.4. So the 19.4 is the approximate answer. And the 35 raised to the 5/6 power, that one is exact. Right? Just like I would leave the square root of 2 as a part of a problem because that was the exact answer. Okay, let's look at the one over there on number 2. Pull the calculator up again and move it. Okay, I've got the 5th root of 11 raised to the 4. So I need parentheses. I need to do it just like I see there. So parentheses, I need to put the 5 in there, the index first. Math. Number 5 is the nth root. Type in 11. Get out of this bracket. Raise that thing to the 4th power. And I get about 6.8. About 6.8. Again, this is the approximate answer, and this one here would have been the exact answer. And moreover, this could have been rewritten as 11 raised to the, well, 5 is the root, and it's making it small. That's going to go in the bottom of the fraction, 4/5 power. Okay, and back over here on this one, 35 is the radicand, 6 is making this smaller, so it would be the 6th root, all of this raised to the 5th power. So we should be able to transfer from one of those to the other one. Okay, one last thing on this one, and that is solving some equations. So whenever you solve an equation, you know you're always doing the inverse operation. So if it says x plus 2, you minus 2 to the other side. Instead of multiplying, you would divide. Instead of squaring something, I would take the square root. So the inverse of squaring is taking a square root. So the inverse of raising a number to the nth power would be taking the nth root. And that one didn't animate. So we can use that inverse relationship. Inverse just means that it's undoing what you just did before in order to solve equations that have nth powers in them, like this. So 6x cubed is equal to 384. So of course I would divide both sides by 6. Cubed is equal to, go in there 6 times with 2 left over, 64. And what is the cube root of 64? So that's what I would be doing. I'd take the cube root of both sides. Cube root of both sides. So x is equal to 4. And I'm done. I don't have to do plus or minus on that one because it was an odd root. Okay, over here on number 2, I would just treat this as something raised to the 4th power, and I deal with the 8 at the end, the minus 8 that's in there. So I need to take the 4th root of both sides, 4th root, and I would have on the left-hand side x minus 8 is equal to, now since this is a 4th root, which is even, I should have plus or minus 4th root of 100. Now I know that that doesn't simplify with the fourth root because 100, there we go, 100 is 10 and 10, and then each one of those is a 2 and a 5, 2 and a 5. And if I'm going to simplify it with a fourth root, I need 4 of those numbers for something to come out. So that can be left like that. And then finally add your 8 over, so 8 is equal to, x is equal to 8 plus or minus the fourth root of 100. Now, see if you can wrap your brain around this. This is going to blow your mind. I'm going to rewrite that fourth root of 100. Even though I said I couldn't do it up there, I'm going to do it differently. So 100 to the 1/4 power is the same thing as 10 squared to the 1/4 power. Would you agree? Of course you would. And then that, like a power to a power, so I can multiply the 2 times the 1/4 on the exponents, and that is 10 to the 1/2 power, which is the same thing as the square root of, not 2, what? 10. Crazy. So I could have rewritten this as x is equal to 8 plus or minus the square root of 10. All right, there you go. There's objective 1 done.